Okay, this is lesson 19, Algebra 2 class. Okay, today we're going to talk about value word problems and similar triangles. So basically, we've had word problems in which one or more statements in the problems are about the value items. For example, we could say nickel. Every nickel has a value of 5 cents, or the number of nickels, or the number of dimes. So let's just begin with word problems that contain two statements of equality that lead to two equations and two unknowns. So let's look at example 19.1. It says Kara Magoo had 50 nickels and dimes, whose value was $4. How many of each kind did he have? Well, we know he had 50 nickels, yes? So we're going to say n of n equals the number of nickels, and n of d is the number of dimes. Yes? So he had 50 nickels and dimes. So he had a total. So the number of nickels plus the number of dimes equals 50. Because we said he had 50. Didn't tell us total, but the way the sentence is written, we assume that he had 50 nickels and dimes, whose value was $4. Well, we know a nickel is worth what? 5 cents. So 5 cents times the number of nickels plus 10 cents times the number of dimes equal $4, because they said they had a value of $4. How many of each kind do we have? Well, don't we now have two systems of linear equations with two unknowns, and we can solve by either substitution or elimination? Well, first of all, let's get rid of these decimals. All right? Well, this one has 2 places, and that one has 2 places. So we multiply the whole thing by 100. Remember, we said we can multiply an entire equation by some number and then not change it. So if we multiply this, this becomes 5n plus 10n of dimes equals 400. All right, so now we've got that n of n plus n of d equals 50. So we can either use the substitution method or we can use elimination. Let's go ahead and use the substitution, and let's solve for, say, n of n. So this becomes n of n equals 50 minus n of d. And I simply just use algebra on that to change that. Notice. See? All right, so I'm going to rewrite it up here. So my two equations are n of n equals 50 minus n of d, and 5n of n plus 10n of d equals 400. Okay, so now I simply am substituting this for what? N of n. So 5 times 50 minus n of d plus 10 n of d equals 400. I simply have to distribute. This becomes 250 minus 5 n of d plus 10 n of d equals 400. All right. Now I'm going to combine like terms. So 250 plus 5 n of d equals 400. Now I'm just simply here solving for n of d. And I'm just using my basic algebraic steps to solve an algebraic equation. Divide by 5, divide by 5. So the number of dimes is, or nickels, no, number of dimes is equal to 30. So how do I find the number of nickels? I simply put it back into this equation, yes? Which is 50 minus 30 gives me 20. And that is what my number of nickels are. I have 20 nickels and 30 dimes. As simple as that. So let's look at another example just like that. It says the fishmonger sold, this is 19.2, sold codfish for 6 pence each and mussels for 1 pence each. If he bought a total of 26 items and spent 86 pence, how many codfish did she buy? Okay, pence is the price. I don't know what that means, if that is even such of a thing, but you have to kind of decode their words and see that that's what they mean. So, he sold codfish for 6 pence. So we're going to say the number of codfish plus the number of mussels, because he had a total of 26 items, or 26, yes? And he said that the codfish sold for 6. So 6 times the number of cod plus 1 times the number of mussels equals 86. Okay? Because he said the number of cod cost 6 pence, the number of mussels were 1 pence, and it cost him a total of 86 pence. So that's how we get this. And we can drop this one. It's an implied one. We don't ever have to write it. So now, I think I want to use elimination. And I'm simply going to multiply this by a -1. So this becomes a negative n of c minus n of m equals -26. I simply add them. That goes away. This becomes 5nc equals 60 divided by 5. So the number of cod fish was 12. Is that what they asked us for? They asked us for how many codfish did she buy? 12. If they want to know how many mussels we bought, we simply would go in here and do 12 plus the number of mussels equals 26. Subtract 12. Subtract 12. So the number of mussels would equal 14. Simple as that. All right, so you're just substituting and saying number of cod, number of mussels. That's why we learned subscript a couple of lessons ago. So now moving on, we're talking about triangles and their angles. Okay? When 2 angles in one triangle have the same measurement as 2 angles in another triangle, then we say the third angles are equal. And they can use the statement written like that. This is a shorthand version of that statement that says if 2 angles when 2 angles in one triangle have the same measure as 2 angles in another triangle, then the third angles are equal. So let's look at an example. Let's pretend like they're similar triangles. Okay? In this, the tick marks show us that the 2 angles, that angle A is equal to angle D. And then we see that the tick marks for angle B show that that angle is equal to angle E. Yes? So, some authors say that this is equality. It gives the third angles no choice but to be equal. So they call it the no choice theorem. So we'll do a simple 3-step proof to prove that. So we said the sum of these, so angle A plus angle B plus angle C equal 180. And we said angle D plus angle E plus angle F also equal to 180. Okay? Now we're saying that these two are equal. So let's figure out, angle C is equal to 180 minus angle A plus angle B. Okay? And angle F over here is equal to 180 minus the sum of angle angle D plus angle E. Are you with me so far? Yes? Okay. And if we simply substitute we replace angle A with its equivalent angle D. Oops. And then B with its equivalent angle. All I do is distribute that negative through. E. So basically I have the same equation. So then they're equal. So therefore, since angle C and angle F are both equal the sum, these two angles must be equal. So let's look at example 19.3. It says find x and y. This is where I have a hard time just drawing all these weird shapes. Okay, how would we find that? Well, we know that those angles are equal, and we said the side opposite an angle is related. Yes? So to find this, we can use a scale factor. So what do we know? We know that, and how do we find the scale factor? Let's look at 4. This angle goes with 4, right, because it's across from it. Likewise, this angle goes with that, and these two are equal. So we can say 4 times the scale factor equals 6. Okay, because they're proportional. So we just divide by 4. So our scale factor is equal to 3/2. So now we can say, all right, this one and this one are equal. So that is what? 7 times the scale factor 3/2 equals y. And we get 21/2 equals y. So how do we find x? Well, x is across from that angle, and which is, because we said if two of the angles are equal, then the third angles must be equal. So this one must be equal to this one. Yes? So what side does fit? 5. So we say 5 times scale factor of 3/2 equals x, or simply we get 15/2 equals x. All right? So now you just need to know that when two angles and one triangle equal to two angles in the second, then the third angles are equal. And we said, because these are similar, they're not congruent, they're similar triangles, so the angles can be the same, but not necessarily the sides. Because to be similar, that means it's the same shape, just not necessarily the same size. And because of this, they're proportional. So if we said this angle goes to that side 4, so we can say 4 times the scale factor will give us what that one is. And then that's how you set them up. You have to figure out the scale factors and then go from there. So do examples A, B, and C. And your code for this lesson is going to be pop quiz next week. Put pop quiz on the top of your paper for homework lesson number 18. Okay? In class.